solve another Leetcode problem. Number 51, increase. So for this problem, I think we are familiar with the rules of the chess. Yeah, so where the queens can go inside the board. I'm not going to describe everything because it's straightforward. I think we can understand. So the queen can place in a chessboard. So this is the first position. If we, yeah, in the first row. So the second rows would be here, and the third rows would be here, and fourth rows would be here. Yeah. So there are in total two combinations of the cues. Now let me go to the whiteboard. Now let me go to the simulation first, and then I will go to the whiteboard. After that, I will go to the code editor to finish the coding. Yeah. Now let me first, yeah, go to the visualization of what is the backtracking. Yeah. Yeah, now let me first go to the visualization of backtracking. So yeah, now let me first go to the visualization of the backtracking of increase problem. So basically, if we are giving a increase problem, it's like this, and then this is our board, and then I'm going to simulate what it looks like. Yeah, so from the first position, we go from the first column. So we're gonna find the next position, and then use the backtracking to find the next one. So that is not possible. So this one is possible, but then we're gonna find that's not possible. We go backtracking, and then it's not possible. So we find this position, and then continually we find in the second column, and then go to the third column, we find another one, and then go to the fourth column, we find another one. So this is a one combination of the increase. It can go like this kind of positions. Yeah, so this is only one situation. Now let me go to the whiteboard to explain more about the increase problem. Yeah, so basically for the backtracking, so this is an empty board. So for the first position of the queens, we can go at the top left corner or the right top right corner or in the middle between. Yeah. And then for the next positions, we continually use the backtracking. So I'm only going to focus on this one. Yeah. So if the first position goes from here, and then the next position should go from here. Yeah. And then the third position, the third row should be in this position. So this is different from the simulation. In simulation, we go from a column to column. Here is a row to row, first row, second row, but it doesn't matter because the board is a square. Yeah, it is a 4 times 4 or 8 times 8. Yeah, so this is the third position, and then the fourth position we find a combination. So this is one. So another one, it is start from here, it goes from here, and then the third row and the fourth row. We know this is another combination. So what we're gonna return? We're gonna return this two board. Yeah. Now let me go to. Now let me explain more about how we are going to design this algorithm. Yeah, so in the second slide, I'm going to design this algorithm. Normally, I'm going to use backtracking to from the first row to the second row by row. I'm going to use the backtracking. So for each of the rows, I'm going to check if, for example, if this, yeah, for example, I'm going to check. Yeah, so for example, this is the first row. I'm going to put this position inside a column set. and inside a diagonal set. Yeah. So for example, here I'm going to put it inside a column 1 set. Yeah. So for the next position, it means for the next row, I cannot go to this position. And also, I'm going to put it inside a positive diagonal set or negative diagonal set. Yeah. And it means the next position, it cannot go to these 3 positions. It has to be here. But how I'm going to design it? I'm going to design it something like this. So there are some properties of the column to rows. So if the row minus column, for example here, this one should always be 0. Yeah, because 1 minus 1, it is 0. Yeah, so this one should always be 0. It means I can put it inside a R minus C negative diagonal set. Yes, because these ones should always be the same. Yeah, and as you can see, this one minus 1 and minus 1 here, and here minus 2, and this minus 3. This is because this is a R minus C, and here is also 1, 1. It's the same. Here 2, same. It means I can put it inside a negative diagonal set. It means if I put this position, if my query is in this position, for the next time I cannot put in this place because in my set I have already have a 0 inside. I cannot put another 0. Yeah. Similarly, I can also use R plus C to represent a positive set. For example, this one and this one. This is R plus C. It is 1. Here is also 1. And here always be 2. And this one always be 3. And here always be 4. This means if I put it inside a positive set, for example, this one, I cannot put it here because I've already put a 2 inside my set. Yeah. Now let me give you an example of all combinations. For example, if here I have a query, put it here. It means for the next position, I cannot put it here because I've already put this number. Yeah, put the column. For example, here I will put a number 2 inside my column set. It means I cannot put for the next rows, I cannot put this position. I cannot put my query in this position because I already have a column, have a 2, put it inside. In column 2, I've already have a position. Similarly, for this one, I cannot put it because it's also the same value. So this is the positive diagonal set. And also for this one, I cannot put it here because here is minus 2 and here is also minus 2. So in this way, I can use backtracking to find all my combinations and then get the result. Now let me go to the code editor to finish the coding to prove this algorithm really works like this way. Yeah. So as I said, I will define 3 sets: the column set, the positive diagonal set, and negative diagonal set. So from the beginning, they will always be empty. I'm also going to define a result and the board because I'm going to put the board inside the result. The result will be empty array and the board, it will be the dot string. Yeah, so the dot string should times n for I in range n. Yeah, so inside the board from the beginning, it is always with a dot. So this is what the question asked. Yeah, so if there's no quiz put inside, we're going to put a dot. So this is the dot. If we find a quiz, we will put a capital code inside the position. Now I'm going to use a backtracking. I'm going to define the backtracking function. I can go backtrack row by row or column by column, but here I'm going to use row by row. And inside, I will define my backtracking function. And here, I will put a path. Yeah, and later on, I will define my backtracking function. After that, I'm going to call the backtrack. Yeah, it will start from row 0. After call, I'm going to return the result. So now let me define the backtracking function. So what is the conditions for return if we find a result? So if the row r equals to n, this means the r from the beginning it is 0, and then it goes to 1, 2, and 3. After r equals to 4, we're gonna return a result. So what is the result? Should be append, something inside the board. So inside the board, so it will be an array, and an empty string should draw something inside the board. So the board I will use a b, and for b in board. So this means if I find something, so this is my board. So one item inside the board, it is this is the result, but except that this is my board. So let me copy it here and put it here. So this is one of my board. I'm going to take an item out of the board. So this is B. So the empty draws B string. I will get something. So this is only one of the boards. Let me give you an example. So this is one of the board. So this is the B. For B inside the board, it is this one. Let me give you a more clear example of what is the board. So inside the inside the board it will be let me print the board. So this is the result. After draw it will get this result. Let me print the board first. Let me give you an example of what is the board and what I'm going to do for this board. So here we are going to have a board. It will be something like this. So if I find one solution, so this is a B for B inside the board. So empty dot draw this B, it means I'm going to have a string, something like like this, dot 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 dot. And then here is an array. It means inside this array it will be something like this. After I get something like this, after I get something like this, I will put it inside my result. Here, in order to reduce the time, I'm going to have a return. Now let me try to write the backtracking function. So for the backtracking, we can use for I in range. So here I'm going to use C. So for column in range n, so here from the row R, so row from the 0 and column I can choose from 0 to 3. If n equals to 4, so 0 to n minus 1. So this is the column. So if column not in column set and R plus C not in positive diagonal and R minus C not in negative diagonal. This means I can use backtracking, because it's not inside. Let me put it like this. So if it is not inside, I can put the values inside. I can put this C and R plus C and R minus C inside the set. So the column can add C and positive diagonal can add R plus C. Similarly, the negative diagonal can add R minus C. And after that, I can put the Q inside the position. So the board RC should equal to capital Q. If I finish all that, I can use backtracking to find the next position. So what is the next position? It should be the next row. Yeah. But if I didn't find, I mean, yeah. So if for each of the, so if we didn't have this condition or we didn't have that condition, we should use a backtracking to go back. Yeah, to go back and then go forward again. So how should we go back? It's also the same. We just need to copy these lines of code and recover it back. Yeah, to the previous step. Recover it to the previous step. So here the column should remove the C and positive diagonal and negative diagonal should also remove R minus C, and after that the board should be set to a dot. Yeah, so this is basically the entire code, I believe. Now let me run it to check if it really works. Yeah, so here let me check. Here remove, it should be remove. So where is the board? So here I should use board, it's a typo. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it can pass all the testing cases. Even I here print a board, it didn't reduce the speed of the algorithm. Yeah, and now let's analyze the time complexity. Let's check the value of n first. So the maximum of n is 9. Yeah, but it doesn't matter. Yeah, so let me go to the PowerPoint to analyze it. Yeah, so for the backtracking, if it is 9 times 9, for the first position, yeah, let me draw something about it. So for the, yeah, I'm not going to draw from here. So for the first position, I'm going to use this image. For the first position, we can take a position from 9. Yeah, because we are going to use, we've already used the trimming for the backtracking. So for the first position inside one row, we have 9 positions. What about the second position? Yeah, the first row we have 9 positions. For the second position, it is 9 minus 6. Yeah. So for the next one, it is even less because it should be even less. So it seems like n to the factorial n, but it should be always less than factorial n. So for factorial n, it should be okay. Factorial 9 is not a big number. So this is the time complexity. But actually, as we know the backtracking, it should be always less than factorial n. Yeah. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like that. Bye.